Awesome. So now we will have a series of lightning talks, and Antip, the head of VIETAI teaching team, will be leading these talks.
Hello. Hello, everybody. My name is Nguyễn Viết Tiệp. I'm a lecturer from University of Information Technology. Oh, sorry.
Okay.
And 10 years ago, I graduated from University of Science under supervision from Professor Trần Minh Triết. And I also now working at in VIETAI as academics. And today, our team, including Hanoi and Saigon teams, will bring to the summit 8 lightning talks. And first, I want to introduce. Here, the profile picture of the speaker today. First, why I want to introduce to all of you about the content of the foundation course. For the first week, we will review about mathematics. We want everybody and every student understand that all the data can be represented by vector, matrix, and tensor, and all the model in machine learning and deep learning can be represented by using the probability theory, and all the model can be trained using the tool of calculus, for example, derivative with gradient-based approach. And to implement the model, we use a programming language, and Python is one of the best choice with a deep learning mode, with a deep learning framework, and we use TensorFlow as the best one for the course. And in this week, we want students to understand that all the computation can be represented in the graphical model, and we do not need to take care about how to calculate the derivative function of a complex function. TensorFlow will do it for them. And another useful tool is TensorBall. Using TensorBall, people can we have an overview about the training process, and we decide to stop early stopping the training process. And for the next week, we learn about 3 basic models: linear regression, logistic regression, and softmax regression. The first one is linear regression, and the second one is extension of the first one. We have an activation function to classify the object to classify the data into 3 classes. And for the multi-class classification, we use softmax regression. And for the assignment, we do experiment on 2 datasets. The first one is Vietnamese vehicle dataset. This dataset is collected from through most familiar objects such as motorbike and car. And the second dataset is fashionist for multi-class classification. In the next week, we will learn about the neural network. This is an extension of softmax regression. If the complex problem cannot be solved by softmax regression, we can increase the number of hidden layers and increase the number of neurons. And for the assignment, we do on the Batman dataset, and a very famous dataset is MNIST. For the next week, when we working with high-dimensional data, for example, image, we may have millions of pixels. So the number of parameters, if we use neural network, is very large. For example, billions of parameters. So CNN convolution neural networks is a an extension of neural network that decrease the number of parameters to millions. And with the development of internet, we have a lot of data with very large scale, and we can train with CNN. And for the assignment, we do on the semantic segmentation. It's a type of classification in pixel level. And in the left, we can see that the original image. And in the second, in the right image, we can see the image can be classified into the three class. The black region is background. The second region is the motorbike, and the third region is person. So we classify in pixel level. When we're working with sequential data, for example, video, text, time series data, we use a very advanced model, recurrent neural network, RNN. And using that model, we can improve, we can solve many problems. For example, one to many, many to one, and many to many problem. And for the assignment, we do on a real data set from collected from foodie review. And we can see that in the red box is a comment of a user, and we classify it into three kinds of sentiment, positive, negative, or neutral. For the last model, we will learn about the attention model with machine translation problem. And in this model, we try to train on another Vietnamese data set. We translate from English to Vietnamese, and the data we collect from TED transcript data set. And here is the result we can see in the right hand side. It translates from the English sentence. I took my grandmother to the end of my life, and the result is tôi đưa em đi đến cuối cuộc đời này. This image is collect from our student assignment. It's a funny case. For the week number 9, we have guest lecture to make our lecture more diversely. We invite anh Hưng Ngô, bạn Thư Nguyễn, bạn Dung Thái, and bạn Trịnh Hoàng Triều to give guest lecture offline and online. And for the last week, we party. we run certificate to student, and Mr. Thắng will have a last lecture to review, to summarize all the knowledge that we have learned for 9 weeks before, and he introduced advanced model that he learned from Google Brain. So that's the all of our content of our foundation score, and we hope that for the next score we will operate it in the central of Vietnam, for example, maybe Huế University. Yes, Quy Nhơn. Yes, okay. Okay, that's all for my presentation, and for the next okay. That's all. Lightning.
So good afternoon, everyone. So my name is Phương Hoàng. I'm a founder of Graphics Minor. So today I present to you a topic from simulation to AI. So let's see. So this is a very basic idea about Graphics Minor. We were lucky because we were selected for the Case Startup Grand Challenge this year, and we entered the second round of IBM AI Sprite. I'm not sure for the third round, but hopefully we can go through. A brief information about me. I got my master's degree from Posttech in Korea 4 years ago about haptics and VR. And I fell in love with Bayesian approach in ML and DL. And I and my friends, all these guys together, we started from zero. I mean, a kind of garage startup. And now I have my pleasure to show you what we have done so far. So this outline for today topic, very basic one for computer simulation and AI. So think about computer simulation. Normally you think about in game industry, in VR, AR stuff. But you know that in medical training, the amount of data in medical is huge. So yesterday, like only 50 megabyte per patient, and today is like 20 gigabyte. So tomorrow, you know, the full cell data with the MRI and the CT, so the system can reconstruct the 3D human heart. The question is like, normally we think about medical data for medical imaging diagnosis, but think about it in different way. Suppose that you are a surgeon. You can touch the patient heart before you actually do surgery. It's going to be great. So with haptic rendering, actually you can touch. The device is over there. It's a small robot. And you can have a try. With the robot, you can see now the man who's studying in medical training. Now he can touch the human heart before he do real surgery. So it can be a kind of a wet dream for many heart surgeons, right? So even you can listen to the heartbeat. So computer simulation, I think is huge. It's huge for many applications, for medical training, and now I will start to education. So students, they are curious about everything. They are very creative. The question is, can we foster and nurture their creativity and curiosity to the next level? Let's see. So normally, students in Vietnam, in China, Japan, Korea, they study 12 years for exams. It's painful for them, for their family. So I mean, investment for education shouldn't be for exam, right? It should be for students to apply their knowledge in real practices. So there are many makerspace for students around the world. However, there are many students who don't have privilege to access the facilities. So we are a virtual makerspace for students. We apply computer simulation for education. So we created EduC, a simulation and AI education platform for students and teachers around the world. And we support, I mean, we cover STEM subject. We try to become a kind of knowledge sharing platform. And, you know, students, they have the app. They can learning by experimenting, learning by sharing in the same platform, and they can learning by collaborating with a virtual assistant. In terms of teachers, we do support teacher with the analytics dashboard. And the image show you is a kind of all kind of scenarios, all kind of gamification scenario for students they create using our platform. So instead of playing games with their smartphone, now they can create many games for educational purposes. So let's start by very basic user case. This is physics curriculum number 8th grade in Vietnam. Each year, millions of, I mean in 8th grade, millions of Vietnamese students, they were struggling to figure out the problem in physical textbook. Can you predict the trajectory of bike wheel when a bike is moving? Can you? This is the answer show up in the physical textbook. I'm not sure about this is correct or not. But let's see if students they can create their own virtual experiment and they can create their own bike. And now you can see the bike very trajectory in a intuitive and interactive way, right? Okay, so in terms of virtual assistant, many people asking us about, how can you apply AI for your system? It's a very, very critical question for many startups. And we do think that we try our best. And thanks to Dr. Thang Leung for his mentorship for us to build up the virtual system with question answering system. I mean, normally students, they have many questions, so they can ask for the virtual assistant. And with the open-ended question answering system, students can freely gain more knowledge. And for recommending the appropriate contents for students, we utilize the conditional restricted Boltzmann machine. And basically, this is kind of very basic model, and we try to maximize the likelihood function using the contrastive divergence algorithm. So students, they love physics. We recommend optics, microelectronics, and many other subjects for them. So the recommendation system is there to support students. So since data is the king, and you guys may know about learning to play Atari with deep reinforcement learning. But the next step for deep reinforcement learning could be learning to play A to C, right? And right now, our progress in the market, more than 5,000 students from 4 high school and middle school in Vietnam use our app for their teaching and learning activities in their classroom. And you know that we strongly believe that we can change the way students in Vietnam, in Korea, and many other countries around the world with simulation and AI. Thank you for your listening. Good luck, good luck.
Yeah, okay. Hello, everyone. My name is Sun. I'm a teaching assistant at University of Science. I'm also working as AI researcher at Oli Technology. I'm also a lecturer at the AI teaching team. Today, I would like to introduce our Vietnamese chatbot for points of interest. So nowadays, many documents have been created and published on the internet. So search engines like Google have helped the user to find their expected information. However, the result are many documents and many websites. So the user needs a lot of time to look at every document to find the expected information. In such situation, Google Assistant have helpful by giving an answer to the user question quickly. My team and I are working on a virtual assistant similar to Google Assistant, but localized for our Vietnamese language. And the Vietnamese VOI chatbot is an important feature for the virtual assistant. And the system focuses on 4 types of information corresponding to 4 types of questions: as address, as list, as time, and as distance. And for the first one, as address, in some situation, you want to go somewhere, but you don't know where is it. So in such situation, you can ask the system to find the address information. Regarding the next one, as list, we can consider the system as a symbol recommend the system. The system can provide a list of places that's suitable with the required information from the user question. For the next one, at time, such what time does the đầu mối market close or open, and the system can answer the question about the business hour of the specific place. For the last one, as distance, the system can answer all the question about the distance between two places. For example, how far from Lutaco Tower to University of Science. Here is the architecture of the system. There are three main components in the system: dialogue manager, POI understanding, and POI answer. For the first one, dialogue manager, we can consider it as the connector that connects the user and the system. It also captures the contact information between all the questions in the conversation. For the second component, POI understanding, it will help the system understand the question from the user. So it has two main models, classification and slot filling models. For the last component, POI answer, it will receive the information from dialogue manager and vary the information in the database and return an answer to the dialogue manager. And we can see easily the flow of the system based on the number. So next, I will introduce two models in the component POI understanding. Yes, for the classification process, we use the CNN with one layer of convolution on top of book vector from this paper. And here is the model architecture for an example sentence. For the next model, for the next process slot filling, we use the by LSTM CNN CRS model from this paper. And the author of this paper used the CNN for encode the character level information to get the character level representation, and then concat it with word embedding, and after that fix them to the by LSTM model. The result from by LSTM model are fed into CIF layer to encode the whole label for the label for the whole sentence. Yeah, and yeah, let's take a look at a demo video. In this demo, for each type of question, we show two examples. And the first one about ask address information. Yeah, for example, nhà thờ Đức Bà ở đâu vậy? Thì yeah. And for the next two, for the ask list information. For example, tell me the list of coffee shops on District 3. And in this example, is coffee house, sorry. And for the next two questions, ask about the time information. The system can answer about the open closed or the place is open or not. Yeah. And for the last one, ask about distance between two places. For example, how far from Lutako Tower to University of Science? Yeah, that's all. Thank you for your attention.
Okay, thank you, San, for your interesting presentation. Hello, everyone. My name is Bảo Đại. I work as a lecturer for VIETAI organization, and I am also an NLP research scientist at Norex. Today, I will be the next speaker for our lightning talk session, and I will share with you about my recent work in Norex, which is genre-oriented web content extraction with deep CNNs. Okay. First, I would ask you a question. If you look at the figure on the left, the article, which part is considered to be the main part? And the same for the figure on the right, which is the list viewed website. Which part are considered to be the main parts? Okay. So let's go into detail for each fingers. For example, as you can see, this is the article website. There's many parts on the article website, right? There's sidebar, title, image, and the content. And the same for the list view website. There are many parts. As you can see, there are many headphone, over ear or on ear or in ear, for example. And yeah, I'm sure that you agree with me. The main part is in the read boxes. Okay, so in terms of the article here, we should go to the page and we should read the content here to know what the page is about. And we tend to ignore those things on the sidebar. And the same for header, footer, navigation, etc. And for the list view website, yeah, we tend to read the content on the read boxes to know what the items are. And we also ignore the things on the sidebar because it doesn't contribute to the main content, right? So that's what we call content extraction, website content extraction. And we want to do this. We want to build a model to have us extract the content on the website automatically. Okay, this is the definition of the problems. The input of the model is a website URL, and the output is the main content on the website without any noise, without the header, without footer, sidebar, navigation, etc. As easy, as simple as that. So this is the whole thing I want to share with you today. And the question is, why do we need to extract the content on the website? Or what are the benefits after extracting the content on the website? So I would say, in terms of research, we usually use common and famous data sets. Or for example, I list here, such as 20 news groups or Yelp's review for sentiment analysis. But in industry, we meet another problems. There are different requirements, different labels. So we need to collect the data. There are two different worlds, two different problems. In terms of academia, we need to build something that is novel, fancy, and address the previous work issue. But on the other hand, in the industry, we need to build something that can be used to address some specific demands. And sometimes the data set is not available yet. We need to collect them manually. And one way to build a large corpus is to collect the documents on the website.